One of the mechanisms that we're going to be adding is a concept of a freeze, where we just say, freeze this particular version of these packages, freeze these particular packages, don't move them. And then regardless of what updates are available, it will not move those things. Barring that, if you need to do that today with the express bits, you can always do it again by installing a package that has an incorporation dependency on exactly the version you want. And it will just lock that thing down and it won't move. And so all our mechanisms internally are done through package dependencies. So you can leverage those facilities to achieve the desired behavior very readily. The only way that you can end up in an inconsistent state is if you're installing, well, in the case when we installed GIMP, for example. Here. This operation is done on the live system because we didn't create a new boot environment. And if we were doing these operations, let's see, if we were doing the install phase, we could Control-C right in the middle of this operation. And we attempt to roll back to the previous, there's a couple mechanisms you have available. First of all, you can repeat the operation and it will complete, because the last thing we do is figure out that we're going to install the new bit. So that actually works. We also create a snapshot before beginning the installation operation on the live system. So you can do a ZFS rollback on the live system and back up to where you were. So if you Control-C in the middle, you can just say ZFS rollback, and it tells you that when you interrupt the packaging system, you can roll right back to the file system while you're running to where you were. Yeah, that probably that covers it. And since the only thing you want to be careful of is a rollback if you're making other administrative changes at the same time, you'll lose those because it takes the whole root file system right back to where it was. Yes? It doesn't roll back automatically, but it tells you the name of the snapshot so you can roll back yourself.
So if I interrupt that,
you can just roll it right back. The other thing you can do, of course, is that if you decide to go forward, you can repeat the operation, and that works correctly. Today, it's snapshots the root file system. There's information about what constitutes a boot environment that's kept track of in the file system in the user properties itself. If you're interested, look at the user properties on your ZFS file system on your root data set, and you'll see that information. We don't. That's one of the things that, as we're adding shared file systems, one of the things you cannot do is package stuff into a shared file system, because then when you boot the other boot environment, it's inconsistent. Right. So one of the checks that's coming, we're adding the ability to go to shared file to automatically make some parts of the file system shared. That's one of our projects that I'm working on. That will be. It will be an error to deliver a packaged file to a shared file system. It doesn't work across upgrade, right? It's just, it causes nothing but problems. Yes, it's great for var mail should be shared, var log should be shared, but it's not useful to attempt to have two packaging systems in two different boot environments trying to maintain the same shared file, trying to maintain a consistent view in a shared file system. It just causes chaos. Okay. Some package publication tools. So, package repo command just creates repositories and manages them, allows you to set certain properties on them. It's very simple. Package send builds packages. You can build a new package manifest from a directory, from a tar file, tarball, SBR4 package, I think a CPIO archived as well, if I remember correctly. And it will basically dump out a manifest using the information that's in those bundles. It'll dump out a manifest. The directory one is particularly handy if you're packaging something and you compile it with, say, some open source software. You compile it with desdir set somewhere. It dumps it in there, and you can just package. You can generate a manifest directly from it. Publish actually sends the manifest and the file contents to a HTTP or file repository. and tells you what the fMRI is. Package receive allows you to pull packages from a repository and put them in another one. This is very handy, for example, for those of you who are running behind firewalls or other run rules that prevent you from having a path to the internet. You can completely copy Oracle's repositories this way. Here we go. It accepts SSL keys and certificates, so you can, where you have to have authorization, it knows how to do that. And it doesn't copy any packages it already has. So it can be, you can run it periodically against a repository and it will update and maintain a local copy, basically. So it can be repeated as needed. So package mogrify, it basically allows you to take a manifest and operate on it in a programmatic fashion. We decided the old mechanisms that we used with SVR4 packages involved lots of use of VI and careful hand editing. This was pretty error prone, so we decided to have mechanisms in place that would allow us to do a lot more flexible kinds of operations. So it has a macro capability, and you can use regular expressions to go find things and edit things, move things around. And we used a lot of this to build the initial Open Solaris releases from the SVR4 or similar facility to build things from the SVR4 packages. It allows you also to abort if you find things you don't like. So you can construct various checking situations and then check the manifest content. This is good for those of you who like to make sure that the engineers or the automated build procedures are doing things that make sense. There's also one command I forgot to put on here, and which is funny because I wrote it myself. It's called package diff, which takes the difference between two manifests and print them out in a form that you can readily understand, so it becomes very easy to go to look at things. We have package depend, which actually will generate, in one phase generates, and then will resolve in another phase dependencies against a proto area. This is very handy for groveling through your manifests and figuring out what your true dependencies are. Right now it understands ELF files, grabs the pound bang dependencies, knows how to do Python. Since packaging system is written in Python, we spent some time working on Python dependencies. And it also automatically creates dependencies. If your package has a hard link on a file that's not in the same package, it will automatically construct a dependency to make sure that that package is present. Oh, and it also understands SMF manifests. So it cracks the SMF manifest and reads the dependencies out of the XML. This is going to get enhanced. We would like to make it do other things and be a more sophisticated tool, although we found it pretty handy. You will have to insert some dependencies by hand. We haven't solved the halting problem yet, so we can't find all the dependencies. Yes? No, this has nothing to do with SVR4 package trans or any other kinds of operations. These are manifests. These particular, it's a completely different package form. We do not yet have a single file package format. The one that's coming will be there in the release shortly, is actually basically a compressed archive of a repository, if you will. Because, what's that? No, it's completely different. The new packaging system is a complete change from the old packaging system. There's no correlation. Okay, and the last thing is a package.depod, which is a packaging repository that we use to serve things. Its true function is search and building, it provides search services and builds the search archives. If you don't need those particular capabilities, the ability to do file repositories are much faster than going through this. This is a Python web server, basically. We also, when we do deployments out in anger, out in the, when you see package.oracle.com, that will be running Apache front ends to serve all the static content, because that's much faster for us and scales better, et cetera. We have another couple of tools that we have in place. Package Lint, which runs checks on your manifest to make sure things make sense. Look for things that are broken. with a new packaging system, we're exploring all the possible ways people have of breaking manifests as they learn the rules, so we implemented some checkers. And package merge, which is still being worked on. I haven't put this back yet, so it's not in the first Express release. Although the code necessary, anybody who wants to do that, please let me know, and I can point you at how to do it using the packaging gate, which is out in the open. And this is what's used to blend, to merge packages, multi-architecture packages, build multi-architecture packages from separate ones, and also will allow you to blend them together. So, still being worked on. So, on-disk format, as I alluded to earlier, on-disk format still being done. Complete consistency checking on install. Right now, we don't do enough of this. So right now, it's possible to get in kind of a broken state if two packages think they own the same file. And we're implementing some more checking for this so that it can make sure that there's no way that one package thinks that's a file and the other package thinks it's a directory, for example, as has happened before. Your publishers have to agree on what the file system looks like, at least in the parts where they intersect. Right now, if you expect the system to be able to upgrade and it doesn't, the error messages are, well, a kind way of putting it would be opaque. And so we're working on this. This is something that that's on my plate since I created those opaque error messages. One of the things we also want to do is to take multiple repositories from the same publisher and composite them together on the client side. And this allows us to basically to turf old packages into a historical repository, and then you can add them in if you want them. It turns out that if you give the packaging system 100,000 or 150,000 package versions to look at, it slows down. So we like to not give it too much work to do, and by pruning the set of the old packages that very few people are interested in into a historical repo, that will improve performance pretty readily for us. We'd like to do more complete dependency analysis. The package merge, as I mentioned earlier. Package Lint's going to get some improvements, and we're adding some more cross-repository auditing tools again. And there's for those of you who are developing packages, a run once at first boot or right after we install the package on a live system SMF service that will make it very easy to move packages from back and forth. Yes? Thank you. I forgot to mention the alternatives. That's another thing that's coming. Where we're going to make it possible to basically specify different, select different versions. For example, user bin Python is by default going to be the most recent version on the system, but you'll also be able to change that to point to any of the versions you have installed. So it's a kind of an enhanced version of Debian alternatives. And that should get rid of many of the areas where we've had conflicts between packages before. Right. Right now, we don't have a mechanism planned for that other than to package, receive it, fix it, and then install the fixed version, which given the tool set is probably pretty straightforward, is probably the most straightforward way of going about it. One of the things we're trying to do is to build a consistent, accurate model of what's actually installed on the system. And this would be one of those particular things. And so two package versions that you two packages that you absolutely want to install at the same time, attempt to deliver the same file, we basically have to fix the problem. Right now, that thing is done. The easiest way to fix it is by republishing. You're kind of stepping out on a limb, of course, because you don't know what the dependence, who depends on what. That will be the consistency checking on the install is what we'll be going through there. That's one of the things that we wanted to introduce. We had some problems with this with some of the out in the wild open Solaris repos over time. We moved various things from being directories to being symlinks, and some of the people who were very early publishers never changed their packages. Didn't ever looked at the thing again for a couple of years, and so we ran into problems in this space. This feature is coming. It's not yet there, the consistency checking, but it will be there relatively soon in the development bits. Okay, and distribution level changes. We're going to do more package refactoring. We do not yet have as fine a granularity of packaging as we would like. We install too much in some areas, so we're going to be just splitting things up. We need to do more tagging of actions that are facet specific, the locale and developer support, platform support, etc. By the way, default behavior is to build images that will boot and run on any machine of that architecture. So when you install a Spark machine, unlike previous times, that same image will work on all Spark machines, not just Sun4U or not just Sun4V, but on all the hardware. Unless once we start tagging, you can actually minimize that away, but that's a different issue. And right now, we're still changing, on the development bits, we're still changing the package versions on every build, and that's just a question of changing our infrastructure to detect when nothing useful has changed in the package and to not bump the versions. So that will be changing as well. Okay, image packaging was used to deliver all the Open Solaris releases, and this will be the packaging system that is present on the Oracle Solaris Express release when it comes out any day now. It will be the plan. There are no plans to backport and support it on Solaris 10. We will be. The plans are currently to make it available on Solaris 10 for use as part of the Ops Center work, but it's not. There's no reason it couldn't be made to work there. It's just there's no particular. We're not going to package up Solaris 10 using this packaging system. That would be a change that would be incompatible with what people would consider an update to be, right? Updates aren't supposed to change your world that much. I realize we've bent that rule somewhat in Solaris 10, but this would be, yeah, we might as well throw all the rules out if you change packaging systems in a patch. It's not, I would consider it to be close. The package utility is close to its final version. In terms of syntax, I would expect some minor changes in this in this space. One of the interesting things that we've learned during the development of Solaris 11 are the advantages and downsides of ongoing delivery and development. And if you look at how we used to develop Solaris, which was basically, it was kept internal, and we worked on it, and finally you might have some nice beta programs, and then we pushed it out to customers. And now we've had a much greater, during the Solaris 11 development, we've had much more exposure, and I think that regardless of the open or closed source nature of the operating system, the ability to get at the bits in development is a very useful thing for our customers and is very useful for us in that it gives us good feedback about what's going on and what we need to do differently. And certainly we've learned a lot from the experience, and I doubt that the packaging system would be nearly as successful as it is today without that exposure. In particular, the real world problems that you see trying to download megabytes and megabytes over various less than optimal networks has been helped us really tune the packaging transport. It's made a big difference. Yes? Yes. How does this new packaging system help with dependencies? First of all, the old packaging system had one dependency type, which was require. Okay? We can now untangle dependencies. For example, Python has the default behavior when the Python gets packaged in Solaris is to include Tickle plugins. The Tickle plugins have dependencies on the Tickle package. The Tickle package have dependencies on the X libraries. The X libraries bring in the whole X system. So it's one of these, by the time you compute the transitive closure. So by putting a conditional dependency in the core Python package that says, if Tickle is installed, then install the Python package, the additional Python package that includes the Tickle plugins, then we can untangle that and basically extract from that Python just the core Python runtime without having to have the the whole closure of all possible dependencies, because we can use these new dependency types to relax those constraints. The other part of this is, because we have automated dependency analysis, it's a much more tractable problem to break apart existing large-scale packages into smaller pieces. And this is part of the ongoing effort. This is what I was talking about. We still need to do more of this. Basically, just, SunWCS, which we haven't renamed, needs to be, core system needs to be a lot smaller, right? There's various things in there that can be pulled out and put in separate packages and essentially become optional in the way the system is configured. So that's where we're going with dependencies. The other part of this is trying to figure out how we can minimize the number of, so you can do some analysis of what drivers are needed for your system. So you can uninstall the drivers that are not present on your machine. This allows you to avoid having to patch any broken drivers for hardware you don't have. And again, it's a minimization step. We're hoping to provide automated tools for exactly that purpose. There is always a problem. If the update requires you to rev the package and you have the package frozen, then you have a choice whether to do the update or whether to relax the freeze. Whether to relax the freeze and do the update or whether to stand pat. That is a problem with the way SendMail is packaged. If you're editing, you should not. Are you changing, let me think back on SendMail administration. I believe that, are you running the CF? Are you running the makefile, or are you just directly editing the sendmail.cf? Right, we need to address that problem in the packaging of SendMail. I can talk to you about that afterwards. How to build IPS packages? Yeah, there's information on them in the man pages. We'll be having some talks today about that, and the documentation is not yet as complete, although I would encourage you, we're still doing development in the open on Open Solaris website. There's Package Discuss, PKG Discuss, which is the mailing list that we all hang out on. In fact, most of our code reviews, et cetera, are posted there for those of you who are interested in what's going on, have questions or difficulties. And that's probably the easiest way of figuring out what's the easiest way to do package delivery. Okay? Thank you.